everyone, welcome to the class. Today our topic will be quantum numbers. Quantum numbers. As we know that an atom is having three fundamental particles, right? Electrons, protons and neutrons. And in this chapter, that is the structure of atom, we have already done, that is the discovery of electrons, protons and neutrons. And also we know that the atomic structure or the model of atom. Now quantum numbers basically tells us about the address or position and about energy of electrons. Now we know that the main problem of Rutherford atomic model was it can't describe the stability of atom, right? Because it was only considered the nucleus and only the radius of orbit where electron stays. And when a charged particle moves along according to the Maxwell theory, what happens? When it moves, it loses energy, and if it does so what will happen? During the course of the time, it will lose energy and eventually it will hit the nucleus, right? So the stability of the atom can't be described by Rutherford atomic model. So then the atomic model proposed by Bohr's atomic model fixed this problem, giving the solution that when an electron stays in an orbit, that orbit is having a particular energy. That means according to the Bohr's model, electron is always having a particular energy. So by the quantum number we can guess the position and of course the energy of electrons by the four quantum numbers N, L, M and S. So there are four types of quantum numbers. The first one we could say principal quantum number. According to our address, just like our locality, right? Principal quantum number which is represented by N, and you are quite familiar with the principal quantum number, not by this name, also by this name, the shell number. Okay, the major shell number you have known as K, L, M, N, just like that. That represents actually principal quantum number. For K, N value is equal to 1. For L, N value is equal to 2. For M, N value is equal to 3, and 4, so on. Okay. Second one is the azimuthal quantum number. Azimuthal quantum number, and which is represented by the letter small l. Okay, azimuthal quantum number. And also note that the value of L is from 0 to n minus 1. Number third one is the magnetic quantum number. Which is represented by small m, and the value of the m is minus L to plus L. And the last one is the spin quantum number. Which is represented by small s. Okay, and it is having two values, one is plus half and one is minus half. Now what is represents plus half? If you take, you know that electrons moves according to their axis also, and they are rotating to the nucleus, just like our earth is rotating, the same way rotating the sun, right? So spin quantum number represents plus half. That means if you take the clockwise rotation as plus half, then minus half will be anti-clockwise rotation. And if you take plus half as anti-clockwise rotation, so minus half will represent clockwise rotation according to your consideration. Now why we are taking half, not any other that is minus 3. We could take minus 3 plus 3, or minus 1 by 4 plus 1 by 4, any other numbers. Why we are specifically taking plus half or minus half? These things are coming from the quantum mechanical calculations. Okay, everything is having one equation which we told, that is the Schrodinger wave equation. Everything is having, including you and me also having, uh, we are just having two types of properties. One is wave nature, one is our particle nature. But in case of the macroscopic particle, what is happening there? If you just move back, that is lambda is equal to h by p, de Broglie equation, and through this equation we know that the left hand side represents the wave nature and the right hand side represents the particle nature, right? Because p represents mv and lambda is coming from the wave nature, that is E is equal to h nu. From this equation we are getting the value lambda. This is known as the de Broglie wavelength. So what is the main importance? That is, every particles will have two types of properties, duality theory, and electrons is also having a duality theory, that is a wave nature and a particle nature. And what is the main difference between the electrons and us? That is, we are macroscopic particles, but electrons is microscopic particles. So we can't ignore the wave nature. We have to take the wave nature and we have to take the particle nature both at the same time. But in case of the macroscopic particles just like us, we just only have to take our particle nature, because our wave nature, our wave equation, and if you calculate this, the value will be too negligible to consider. Clear? So all these things are coming from the quantum mechanical calculations, from that part. Now if we take, that is principal quantum number, if we just compare with our address, principal quantum number tells us about the locality where we live. So it tells which shell the electrons will live, electrons are in actually. So in the first orbit, in the second orbit, third orbit, just like that. Azimuthal quantum number represents that in each shell, in each orbit actually, there is a subshell. Okay, now just for now we will take this as a, just for example, a building is there, apartment is there, and each floor is having certain types of design, certain types of architectural design, and room number is also different, and types of room is also different. Just consider this thinking. So azimuthal quantum number represents the type of room. What type of room? If we are getting two values of the L, that means two types of room will be there, not two rooms, two types of room. Magnetic quantum number, if we just tell in terms of our just general consideration, types of room, magnetic quantum numbers, the value of L represents actually the number of rooms. Number of rooms. For each value of L, we will get specific value of the magnetic quantum number. For example, if we are getting the value of azimuthal quantum number as 1, so what will be the magnetic quantum number value? Minus 1, 2 plus 1, minus L2 plus L, that means minus 1, 2 plus 1. So minus 1, 0 and plus 1. Minus 1, 0, plus 1. Three values we are getting, right? So that means three rooms will be there for the value of L, that is 1, magnetic quantum number. Three values we are getting, so three rooms will be there. And spin quantum numbers means, just remember that is for example, if we make this chart, so if we make this chart, that is NLMS. Now if we do that calculations, for n is equal to 1, that means it is the first orbit. Electron is rotating in the first orbit. The value of L is 0 to n minus 1. I am writing here 0 to n minus 1. Okay, so 0 to 1 minus 1 in this case, so it will be 0. 0 to 0, that means 0. We are getting only 0. So L represents what I have told you. L represents the type of room. So there is only one type of room, because we are getting only one value of L. M is minus L to plus L. So minus 0 to plus 0, that means we are getting only 0, one value. So actually m represents the number of rooms. So how many rooms will be there? Only one rooms. I'm just okay. And you could also remember like that way, it is a code number. Okay, so each room will have a different code numbers, right? So we are getting only one code number, that means only one room will be there. And S means minus half or plus half. Now the most important thing, in each room two electrons can stay. Of course they will have different spin. If one is rotating, if one is going upward, that is it is the clockwise direction if we take, so one will be in anti-clockwise rotation. Clear? At first we make the chart and then we will do the configuration. N is equal to 2. For the value of n is equal to 2, L will be 0 to 2 minus 1, right? So 0, 2 minus 1 is 1. So how many number we are getting? 2. 2 values, that means 2 types of room will be there, not 2. 2 rooms, not 2 rooms, 2 types of room, okay? For 0, we will get the m value as 0. And for L value 1, we will get minus L to plus L. So minus 1 to plus 1. Actually we are getting minus 1, then 0, then plus 1. So how many code number we are getting? 3 code numbers. In this case only one code number we get, so only one room will be there. 3 code number means 3 rooms. Is it clear? And minus half and plus half, the spin value will be. For n is equal to 3, L value will be 0 to 3 minus 1. So 0, 1 and 2. 3 minus 1 means 2. So for the value of 0, L value will be 0. For the value of L value is 1. So the value of M will be minus 1, 0, plus 1. And for the value of L is equal to 2, the value of M will be minus 2 to plus 2. So minus 2, minus 1, 0, plus 1, plus 2. We will only take the whole numbers. We will only take the whole numbers. So just tell me, one code number we are getting, of course one room. 3 code numbers we are getting, so it will be 3 rooms. And 5 code number we are getting, so it will be 5 rooms. Clear? And the value will, the spin value will be minus half and plus half. I hope you could understand how the value, that is how many rooms will be there, which type of rooms will be there. And now we are talking about rooms that is known as the subshell. Okay, the room is equivalent to subshell, but just for our better understanding we are simplifying these things and we are taking this as types of room and code number of the room. Clear?